Today I will show you writing the beta function test with GCOV. So here is who am I? I'm Masami Hiramatsu. Usually I'm a tech lead for social understanding team, and but also a member maintainer of the Kernel tracing subsystem, and also Ftracetest. So here is today's agenda. I will start from the what's the function test, and also GCOV, and show that what's the GCOV and LCOV and GCOV kernel, and how to write the function test with GCOV by using that my experience of the Ftracetest improvement. So the first, what's the function test? The functional test is actually that test each function or features of the software, so that it's not the functional level unit test. It's just and not a stress test, and it's a kind of regression test, so that you can use make a function test as a jig. And the goal of the function test is that checking that the function works as we expected, and so that we can make sure no regressions while upgrading the kernel or some other applications. So there are many function tests actually in Linux kernel, like boot time self-test, or test modules, or runtime test, and also self-test, of course. And but there are several usual issues on writing this kind of function test. For example, if we found a bug, why this bug case is not covered or untested, or if we want to write a test, what functions are not tested yet, or what functions are covered? Yeah, those are the issues when we writing the test. So we need some measurement or visualizing tools to show that which tests are covered, not which function is covered. So here is actually the tools like GCOV and LCOV. GCOV is a coverage measurement tool for GCC, so that it shows that which line of the code is covered or executed. And also there is LCOV, which is actually GCOV's visualizing tool, so that it can analyze multiple files at once, and also shows that the summaries and reports in HTML. So here is the LCOV example. This one is the overview of the LCOV. So it shows that there some coverage rate, and also each. This one is a directory how much code are covered. And also, it shows that reports the source code view. So, which lines are covered, already tested, or there is uncovered lines with a red line. So this can tells you which lines are not covered. And it is actually very easy to use as a GCOV in Userspace. You just need to pass these two options when you build the application or software. And after run the test, the program, it output these two files, GCDA and GCNO, And so you can just pass these files with GCOV. It shows that the results. And LCOV is almost same. Just using changing the command, using that LCOV command and also a gen HTML to make a HTML report. And actually, Linux kernel already supported GCOV. We said that it's a GCOV in kernel or kernel GCOV. So actually, it can export GCOV data file like a GCDA and a GCDN file under the debug file system. And so that you can just enable it and test and copy these pseudo log files and analyze it. That's it. To enable this GCOV in kernel feature, you can just enable this configuration, config GCOV kernel, and compile the kernel. There are, of course, another option to specify which, let's say, which one is profile. There is a profile all option in a kernel, but I don't recommend it to use it because it actually covers entire kernel. This means that the several thousand of the data are recorded. Yeah. So to specify that, so that to specify the one subsystem to cover to make a profile by GCOV, you can just use these options. Like GCOV profile, some file, or GCOV profile in the subsystem make file, so that the GCOV only profile those files under the directory or the specified file. So here is how we can write the function test with GCOV. The instruction is very simple. So step one, enable the GCOV profile and build the kernel and write a simple test case and run the test and get check that the GCOV result with the GCOV, LCOV, and find what is not covered and improve or add a new test case and run it, and run this loop until all the functions or features are covered. So, but there is some more notes about the goals of function test. You don't need to cover 100% of the lines because Linux kernel implementation is always evolving, so that we don't need to test all the implementation. And also, Linux kernel code has some more critical cases, like kernel panic or bugs or something like that. Of course, we don't need to cover it. So instead of that, focus on what functions are not executed. You need to ask yourself, are there any possible use case of this code, or any is that a feature or just a let's say error case or something like that? Yeah. So I'd like to show you how we can how I improve that Ftracetest with GCOV. So Ftrace is the collection of the Linux kernel tracers, It including that 10 tracers, major tracers, and more than 1,700 events, and with 42 options and more. Yeah, actually, you can find that many debug.fs files under this directory. And all operations can be done via the Ftracetest interface. So you can use that summer command line command to run a ftrace, use the ftrace. So there is also a Ftracetest. This one is a collection of the test cases for ftrace. So it's written by a shell script and run under the K-self-test. Of course, we can run this independently. And it already includes more than 50 test cases. But and also show the precise logs and the summaries like this. So you can see that there is summaries, run logs and summaries. Let's check the code coverage with the Ftracetest. I run a Ftracetest with GCOV enabled and check that the coverage of the test cases. I found that this one just covers that 63% functions, and of course 22 out of 41 files are under 75% coverage, which one is shows in a red line. So there is room for improvement in Ftracetest.
Coverage is from x86 or ARM devices?
Yeah, currently x86 I'm using, but of course this one is architecture independent part. So that I think the result is same on the ARM or ARM64. Yeah.
We have seen some of the events are not supported on ARM, it seems.
Yes, Ftracetest is working on supporting most of the architectures. Okay. Yeah. So I just clicked one of these files and found this one. For example, this one is not covered. This function, print caret probe event, is not tested, and this one is actually printing the trace output. Yeah, after tracing the data into the memory, and it is not formatted, so that when user reads the trace file, trace log, it just read from the memory and format it to output. And this one is the output function. And this means, of course, Ftracetest has a caret probe test, so that the caret probe is tested. But it seems does not test that the caret probe event output. So I improved the test case to ensure the trace output. You can see that this line, we just previously we just set the event and just clear that. But before that, I just add this line to check that output, trace output. So after this improvement, GCOV shows that the good result. We covered this this function. So I found that several typical untested patterns. For example, functions that are just not touched. Yeah, that is a function is documented but not tested, just not tested. Or the typical pattern is a setting without verified. That's the previous one. Yeah, we just set function and enabled the function, but not verified that that is work or not. Yeah. And also there are some undocumented features. Yeah, we have a code, but not documented, so that the test is not touched it. After fixing those cases, I get a better, let's say, the coverage on the Ftracetest like this. I've added 13, more than actually 13 test cases, and this shows that 70 plus 0.6% functions are covered. So almost 7% improved. And the under 75 coverage rate files are reduced. But it seems that there is room for improvement. So I will continue that. Anyway, I already sent this series to the Test subsystem. So there are some pitfalls, I think. There are some bad signals, like if you test it and found that break something, yeah, that's not test. You found real bugs, so you need to fix it. And also, if you find that the tests make us stress, like OM cure, kicking that OM cure or something like that, this one is also not a function test. That is a stress test. And also, if you start using error injection to cover the function, it is not the function test, of course. So please don't stepping into the dark side. Anyway, so with this experience, I found that there are some good side effect, like improve the documentation, found the all-found function, like the function never called, yeah, and also untested, unused features, and also real bugs, yeah. Actually, there is a GCOV kernel has broken on some architectures, yeah, with or some options. So here is conclusion. I use the GCOV. Using the GCOV is very simple and easy, and also our function test can be improved by a GCOV easily, and in the result, Ftracetest was improved by GCOV, yeah, as I shown. So here are the future work. I will continue to improve that Ftracetest with GCOV, and also I would like to try to improve other tests. And I think that I can make a FCOV like a GCOV. GCOV requires to rebuild the kernel, but I think that Ftrace can make it easily, dynamically enabled or disabled. So that's all from my side. Would you have any questions?
I was using that
Yep.
GCOV, like profile, GCOV profile equal to I. So I have seen the issues with adding the source code. I mean, the source code should be present with the GCDI files. So that's a kind of a huge number of files and the large size in the kernel. So that's made me not to use that anymore. because if you add those extra kernel configuration, the footprint of the kernel is high, and there is no point of having a source code on the target machine to generate all these GCOV kind of reports.
So, yeah, you mean that the cross-comparing code? Yeah. I think that even if in that case you can turbo the result and copy to the host machine and run the GCOV GCOV can find it. Yeah.
Yeah, that's the one way, of course.
Yeah. Yeah. Please.
The experiment with ftrace is nice. Do you know if there's a similar project to see the coverage of kernel with LTP, essentially to see what kind of coverage and how LTP is being improved with that?
I think so, but I didn't test it yet. Yeah. I just started from a Ftracetest, but I think we can improve, use this method to other test cases too. Yeah. There are any other questions?
You mentioned when you enabled GCOV for a particular function you needed to edit the makefile. So is that just something you do when you're doing particular debugging, or is there an option to add it to the kernel so other people can turn it on and off?
Yeah, so that's when you add the GCOV option, GCOV profile option on the makefile, that enable only actually that the GCOV is a compiler option, so that's that only add the GCOV compiler option on that directory. Yeah.
But that's not something you would send as a patch to upstream. That would just be in your local build when you're doing your testing.
I just send a patch for Ftrace case, but I think that it is hard to send each each subsystem. Yeah. So that you need to modify that your kernel locally. Yeah.
Okay. Yeah.
Okay. So thank you very much.